I,
know,
I seen I've seen we have the error, the
check and
formula.
what check and see what we did when x was normal. We didn't know sigma squared and n was small. That was the last thing we did in confidence interval. What do you do?
We use we had to use one of the we had to use one of the distributions
We are using t distribution.
the
Amen.
t distribution. Yeah.
Right? We end up using the t distribution. Okay. Right? And it will be the same formula, and we're gonna do an example with that now, right? But just write the formula down. This is for step. I think I have a number here. That would be for step 6. For step 6, you need to be able to find t value. So, right, t is equal to x bar minus mu naught all over sigma hat on root n. Right? Remember, t distribution, we have to know the degrees of freedom, right? And then read it all. Okay, so let's make a note of that. Right, so again, for those who now logging in and now paying attention, those are the 7 steps that we have to take in a hypothesis test. And we're gonna do one now. Define the variable, state H0 and H1. State the distribution according to H0. So based on what H0 came from, state the distribution. State the level of test, if it's 5%, 10%, 1%. Type of test, lower tail or upper tail. Define the critical region, find the test value, and then make a conclusion. Those are the 7 steps that we're going to take. I'll talk about it. Hey, right? So we're going to do an example, right? And you tell me what distribution we're using after you read it. All right, look at this one here. Right, take a little read. Right, tell me what you think. So you have 5 readings. Once you see 5 readings, right? Once you see a sample size small like that, what distribution we're going to use to solve the question? Badly? What do you think? You only have 5 values in this distribution. So what do you think we're going to use? What distribution we're going to use to solve this test?
Well, they didn't give us the standard deviation or variance.
Right, so we don't have that, and the sample size small. Sample size is 5. So what distribution we using?
T squared again. I mean t distribution again.
Very good. Yes, we're using the t distribution. All right. Do my favor before we start to write it up. It's a 5% we doing, and we had to figure out H0 and H1, right? Just do my quick favor. Find x bar and find actually I feel all in a revising, so I'll give you the formula one time. Sigma hat is equal to sum of x on n, and sigma hat is the square root of 1 on n minus 1 by sigma x squared. Right. So before we start to do the hypothesis test, let's do my favor. Work out x bar and the estimated value for sigma. Hurry up, I'm giving you a few minutes. And then if you want to start, go right ahead. Write down what's H1, write down what's H0, write the distribution and so on, right? Right, but we can do that together. We'll go this part first. What? Message answers earlier. I'd say, yeah, 20%, Yes. Right, but you all got for expand sigma hat. Oh Lord, hey. Anyway, this is last class earlier. Although we respond at all. Oh God. On the message now, you just had to plug in the value they give you. They give you sigma x and they give you sigma x squared. Amen. Thank God.
So I get like a real small value from a standard deviation.
Yeah, that's okay. What do you get for x bar?
1.52. You just take 7.6 and divide by the amount of numbers.
That's correct. What's the sigma hat?
Wait, say sir?
What you got for sigma hat? Gotta pull the gate and like push your hand aside.
From a standard deviation, I get 0.0212.
Yeah, that's correct. 0.021. Yeah, that's correct. Kaylin, check back yours, right? It shouldn't be that. It should be 0.021. That's okay. Anybody else got that? 0.0012? right? So you just plugging in these values here, right? They give you sigma x squared and sigma x. All right, nice. Copy that down. Copy that down. If all the writing at all. You all do right nothing, huh? That's your vision. All right. So now let's go through all the steps of the hypothesis test, right? So remember it's a 5%. You want to see if the wire is impure, right? So let's give it a little read first. If the wire is pure, the resistance is 1.5 ohms. Underline that, right? If the wire is impure is higher, so that's a big hint there. Assuming that the resistance can be modeled by a normal variable with mean mu and standard deviation sigma, find those things. So what will your H naught be? And depending on all of the answers there. So this message, what would H naught be?
The wire is pure.
H naught is what? Mu is equal to what?
1.5 and
Correct. 1.5 ohms, right?
and then the alternative hypothesis is in more than 1.5.
Very good. More than, because the question says if it's impure. Very good. So it's more than 1.5. That symbol will show. And now see how two symbol look into ohm filter me. So all right, then the good, right? Ohms, ohms. Oh yeah. Let's make sure he latch the gate from another door lock at the gate anyway. So let's make sure on the inside is safe latch. Right. So after you do that, right, we estimate sigma already. What would the distribution be? Right? We recognize n is small and we had to estimate sigma. So we recognize that T, right? It will be a T distribution and n is 5 because we have 5 values. It will be 5 minus 1 and the significance level will be a 5% level. Okay? What type of test it is? It is a upper tail test. So your rejection region is that shaded region there. Okay? Right, just do my favor. Do my favor, right? And see if we can just read up that phenomenon. T at the 5% level, 4 degrees of freedom. Right? And then we will write down the rejection region. Rejects if the T value is greater than that value that I just worked out. Buddy, I don't know if I could open that file. Oh, you send it, okay. How much is that? I can't see it because it's quite a
That's
bit.
2.132. 2.132. 132.
Right. So if you're open on the group, you will see how to read it, right? So you read off the value and you'll get 2.132. You read off 4 degrees of freedom and the corresponding probability. Okay? And you'll get 2.132. So basically, here's what it's saying. We are going to reject if the T calculated is more than 2.132. Right? So that's most of your work finished there. We're down to step 1, 2, 3, 4, and 5. Now we're gonna do get the probability value. So we're using T is equal to sigma hat. Right? Sigma hat is the one that we calculate in part A minus mu all over the estimated value that we calculated in part B there divided by root 10. Okay, that's all we have to do. Really, really simple. So X bar is what we calculated was 1. What again? 1.52, I think, yeah, 1.52. The mu value is 1.5. The sigma hat that we calculated was 0.0212, and we find the square root of n, which is 5. How much is that? And that's test value, right? How much is that? Let's plug it in the calculator. Let me see what you got. And the answer is 2.109. Thanks. So it's 2.109. So the t value is less than 2.132 because it's less than it's on this side, it's on the good side. So therefore we do not reject H naught at the 5% level. And we can conclude that it was pure. We can conclude that it was pure. All that in words, we can conclude that it was pure. And that's it. That's all we have to do for hypothesis tests. Okay. Everybody okay with that? All the others are just like what we did last week. You just sometimes you have to estimate, sometimes you have to state by central limit theorem. Are you okay with that? Bradley, you're good. Ravisha, Tyler, are you okay with that? All right, and that's it. That's all I really wanted to do. I just wanted to do a T distribution to show you all how to work it out. Okay, so those are the types that you'll get. The one from last week and the one from last week and this one. So those are all the types. All you have to do is be able to read this and see it, right? Right. While I have all it, let me show you one, right? Apply unit 1. I want to go see this. Right, these are like your number 5 and 6 something, right? Right, what is this one? This is parameter construct and confidence interval. There's a proportion, they give you a proportion this here. Oh wait, that's it. Oh, 24 was that was correlation and time we did that already. Oh, the whole correlation and regret. All right, hold on, that's a bad here. Okay, this is a better copy. Right, mark the there, right? All right, last thing I'll be done. So if you look here, this number 5 confidence interval, we do that already. Parameters, confidence interval, define regression, chi-squared. Hold on. All right, let's look at small one here. What are we doing here? Tell me what would the null on thing be here? So the masses of loaves of bread produced by a certain bakery follow a normal distribution with a standard deviation. So they give you a standard deviation and tell you it's normal. A mean, they give you the mean that they randomly selected, conducted 10% to determine whether the population mean is 450. Okay, so right, just to remember, this is exactly what we did last week, right? So this here is the mu value, right? This is the X bar value. This is the standard deviation, so that is sigma. That is sigma. That's the alpha. And that's the n. Okay, so that's exactly what we did last week. What would the H0 be and what would the H1 be? Let's just answer this and be done, right? So just give me 5 minutes again now, please. What is the H0 and the H1, Ravisha? Okay, anybody. I ain't able. I'm not able. Anybody?
Yeah, the null hypothesis would be the population is equal to 450
Thank
and
you. And
the
H1.
alternative is not equal to 450.
Very good, not equal. So what type of test is this? One tail or two tail?
Well, because it's not equal to 450, I'd say it's like two tail. Because it's not saying more than or less than.
Yeah. That's correct. So it means that here is 90%. So it means that here is 5% and here is 5%. So the value to get the critical value, we have to read off 0.95. And that'll give you a critical value. Right? So you have to read off 0.95 from a normal distribution and you'll get a critical value. By the way, please remember to write this. X bar follows on normal with mean mu and variance sigma squared on n. Very important to write that. Could we go to your tables and tell me what the critical value is? Nah, man, me not help nobody. That's not. Oh. Yeah. Right, so 90% and you have to read up. Remember that two tail, right? So 10% to be divided evenly. Right? So the
Yeah,
shape,
divided by 2, sir?
huh?
Yeah, divided by 2.
You divide 10 by 2 here. So that shaded region here is 5%. So it means that all of this here is 95%.
Okay.
So the value you have to read on the table is 0.95. So the critical value that we're getting for Z is, I said 1.645. So we reject if the Z value that we calculate is less than 1.6, sorry, less than minus 1.645, or if the Z value is more than 1.645. Sometimes we write the modulus of Z is more than 1.645. Sometimes they write that. Okay, and that's it. And then you go ahead and calculate the Z value. What's the formula for the Z value again? What's the formula for the Z value? Very good. Somebody type that real fast. X bar minus mu, right? All over sigma on root n. That's it. Right? Actually, do it from a past now. The question didn't ask us yet, but could you all work out the Z value for me? Work out the Z value, tell me if you reject, and that's it. So in your message, write down what Z is, and if you reject or if we accept. And we done. But I get you. What she got there? The Z calculated, Kaylin said she got minus 1.527. Minus 1.527. Right? Do you reject or accept? Alright, bad news, my father just died. Right, but what do you do? Accept or reject? We accept. Okay? Alright, so that's it all here. Right? Thanks for watching.